All right, so there is me. You can see me in the video box too, but there's a picture of me wearing a suit that I probably don't fit into anymore. But like Sean said, I am Jim Harris. I am from Vertica. I am the Senior Product Marketing Manager, and I am also the host of the Database Projections podcast. It's an audio podcast available on all platforms. And probably most germane to this presentation is you can find the presentation there. So that link that's showing there for the podcast in the extended show notes, because there is an episode of the podcast that actually has the core of the presentation that you're about to hear. You also can hear an audio replay of that. But more importantly, you can get the full presentation. So there's no need to take copious amounts of notes or be concerned about falling behind. The full presentation is available to you. Now, this is going to be a vendor neutral podcast, except for just this one slide. So let's just get the salesy stuff out of the way first, in case you're not sure of who Vertica is. So Vertica is a unified analytics platform. We offer an ACID compliant SQL database for blazing fast analytics at massive scale, plus in-database machine learning and advanced analytics, plus a query engine that can query data wherever it resides. I think of us as database plus plus. So a single Vertica deployment can unify analytical insights regardless of data location and unify data across data warehouses, data lakes, and cloud object storage. We offer flexible deployments. We can run on premises, in the public cloud as database as a service, private cloud, and hybrid implementations. We offer speed, scale, flexibility, and control. We support a robust ecosystem for cloud analytics, and we offer transparent and predictable pricing. So the bottom line here, germane to this presentation, however you cloud, Vertica clouds too. If you'd like to learn more about Vertica, you can contact me after the event, or you can go to vertica.com. So sales part over. So the rest of this very short presentation is only about another 8 or 9 slides, is all vendor neutral. So first up, what business initiatives are driving data analytics? So there's a couple of major trends in the industry. One is analytics modernization. There's the need for advanced analytics for enterprises to be able to evolve beyond reporting to advanced analytics and machine learning. Probably a big thing that we'll be talking about in this presentation is cloud migration. The need to make the most of cloud economics, especially given the reality that hybrid architectures will be here for a long time. Data democratization is another big thing. We need to scale up so that everyone throughout the enterprise, from business analysts to data scientists, can use data without worry of overwhelming systems. And data fabric. We have a lot of analysts to talk about that a lot of enterprise data is just not available to the enterprise, and therefore not available to the analytics efforts of the enterprise, and possibly because analysts are not even aware that some data assets exist that can assist with that. So data fabric means we need to get access to data from the data warehouse, from the data lake, so that all data can be used and it's available to all users. I won't read the bottom of this slide to you, but that is some of the critical capabilities of any data analytics solution that supports these initiatives, and pretty much everything at the bottom of the slide we're going to touch on as we go through the other slides. Excuse me. So since we're focusing on cloud migration in this presentation, what are some of the business concerns about cloud migration? First is the reality that most enterprises can't move all of their data to the cloud due to compliance with existing and evolving regulations. There is also use cases and economics that are now increasingly mandating running analytics where data is born. The era of big data got us into a situation where we had almost a proliferation of data silos because storage was so cheap and so plentiful that everyone was making copies of the data, and now we have data spread everywhere. And nowadays, we really need to stop moving data around and stop making extra copies of data, and maybe try to bring the analytics to where the data already is. In terms of leveraging the cloud, there's been a lot of evolution excuse me, in the cloud space over the last 10 years, but cloud native solutions have the potential threat of lock-in because it can be very difficult to migrate off of them if you get associated with one particular cloud solution. We want to be able to have the freedom to continue to use the tools that we're used to using on premises and not be forced to use cloud-specific tools as we migrate to cloud-based solutions in order to be able to maintain our productivity. Some cloud-based solutions under the guise of ease of use have rather quote unquote black boxes that allow you very little configuration, and that can give you a lack of control that can leave you to bill shock and unexpected expenses from a solution that is in part supposed to be able to save your organization money. And we want to be able to continue to leverage existing investments, even though we might be moving some of our data and analytics to the cloud. We want to be able to continue to query existing sources wherever they may be. So in this presentation, we are talking about a 5-step vendor-neutral framework for evaluating the critical capabilities of any cloud analytics solution that you may be looking at. And this is a very simple 5 verbs: deploy, store, optimize, analyze, and govern. And we're going to go through one slide for each one of these. And again, like I said earlier, the presentation is available. So all of this is basically set up as kind of like a one-page cheat sheet for each of these items. And they'll have this same structure: 2 key questions, 3 bottom line statements, and 6 key concepts. So for the first critical capability, deploy. The key questions here are: how cloudy do you want to be? How much of your data and analytics do you actually want to move to the cloud? And how much flexibility does the solution offer? So cloud computing is a subscription-based service delivery model that promises scalability, fast delivery, and IT efficiencies. And cloud computing can potentially remove a lot of the physical and financial barriers to aligning IT needs with evolving business goals. So some of the key concepts here is: first, the public cloud, which is a shared environment hosted by a cloud service provider. And that's run basically by managed services, or as I like to call them, as you like it, because it's AAS being added as a suffix to pretty much every other letter of the alphabet. But these managed services are for things like hardware, software, and/or applications, platform, and infrastructure. What the key business value is you're offloading the responsibility for installing, configuring, and maintaining these infrastructure resources, moved off of the on-premises data center, and leveraging the cloud service provider to be responsible for those and giving you access to that as a significant potential savings. The public cloud contrasts with the private cloud, which is a dedicated environment that is most often hosted on premises. The industry standard definition of private cloud would be that. There is a secondary definition that some providers use. They'll talk about the difference between multi-tenancy and single tenancy. And they'll say that they can offer you a single tenancy cloud that's still in the public cloud, but you have that cloud's infrastructure and resources all to yourself. But again, that is the secondary definition. The primary definition is a dedicated environment that's hosted on premises. Now, if you're wondering, well, what's the difference between a private cloud and just stuff that's already on premises? And the fundamental paradigm there is the secret sauce, so to speak, of the cloud is the separation of storage and compute, and allowing you to scale those two things independently in an architecture that can best exploit the infrastructure resources. You can actually have that type of environment by bringing the power of cloud down to the ground, so to speak, and use software that fits that model to create an environment in an on-premises data center that leverages that same model. And then you would be able to basically have, again, all of the functionality that the managed services would be able to provide in exploiting that architecture, but on premises. So that's what would be different between a private cloud and other on-premises implementations. Another thing that you hear off of a very key concept is a hybrid cloud, which combines the public and private, so applications can be managed and ported between them. It's estimated that about 40% of existing cloud implementations are hybrid, but many analysts are looking at that increasing significantly in the next 3 years, with hybrid possibly being the implementation model for the future of the cloud. There's another term that you hear a lot that's called multi-cloud, which is not to be confused with hybrid cloud. The industry standard definition of multi-cloud is the ability to execute the same functionality on all clouds, possibly for the selection of one of those clouds for your use, or to be able to have functionality that reaches across and can function on all clouds. Some vendors are using this term, but what they really only offer is the ability to query one public cloud from another. And this happens most often because some of the cloud analytics vendors also own one of the major public clouds. So therefore, the vast majority of the functionality that they offer is on their own home cloud, which they will spin as a home cloud advantage, that you can have one-stop shopping and do everything on their one cloud, but that can be a bit of a slippery slope to vendor lock-in if you were restricted to only using their cloud and you decide or discover that it's not meeting your current or future needs. Excuse me. Another important and related concept is containers, and this is something that separates the underlying infrastructure from the application code, and it's becoming the software development standard, not just in the cloud, but everywhere. Containers are actually have a lot more to do with just software, but one of the great benefits of them is it makes it very easy to port applications from one environment to the next. So when you're evaluating cloud analytics solutions, you should ask the vendor what they have available in terms of containers that might make it a more flexible solution. And the bottom line here is you really want a full range of deployment options, and most importantly, the flexibility to switch between them. And that's probably the most important business requirement when assessing the deployment options associated with cloud analytics. So I'll pause to take a quick sip of my water. So the second critical capability is store. So our two key questions here are where and how will the data be stored, and where will the analytics take place? So a core cloud paradigm that I mentioned earlier is separating storage from compute. And what this allows the cloud providers to do is use commodity hardware for storage, which can significantly lower costs. Some of the key concepts to keep in mind here is storage locations. So where in the physical world will your cloud data be stored? So especially for data that's being moved into the public cloud, regulatory compliance may actually place limits on where physically that data can exist. Even if that doesn't apply to your data, it's usually a very good idea to know exactly where your data is going when it moves to the public cloud. A related concept is storage options. How exactly will your data be stored when it gets there? Like, will it be in a native format? So for example, if you're moving relational database tables to the cloud, will they be stored in relational database tables when they arrive there? Or will they be converted into a more granular format, like a CSV file or a proprietary format? Some vendors use a proprietary format for a good reason, because it offers storage efficiency and perhaps performance improvements. Others, especially as becoming a standard in the cloud, is object storage. The reason that this is important is if the analytics that are going to be performed on your data need to convert from the format that it's stored in to some other format in order to get it ready for analytics, or whether or not that analytics can be performed, however, the data in the format that the data is stored in. When we talk about data moving to the cloud, we usually talk about the data warehouse versus the data lake. So for the data warehouse, we're talking about schema on write, highly structured, ACID compliant, and high concurrency, usually a high number of both users and uses. The reality is the data warehouse is here to stay. It's not going anywhere. That highly structured, ACID compliant format has a lot of value because of all of the things that you can build off of the back of a data warehouse. All of the things that can be built when you can, based on the structure and stability of what's provided by the warehouse, the dashboards, the reports, business intelligence tools, and other downstream processes that can leverage that structure and stability. At the other end of the spectrum, though, there are other types of data that the enterprise might want to get access to, and possibly faster access to. And that's where we get into the realm of the data lake, which largely really came about as a way to rapidly ingest data regardless of what its format was. It's kind of funny to say, but now legacy data lakes is Hadoop. What we used to start with data lakes about 10 years ago, which was stored in the Hadoop distributed file system, and a massive ecosystem grew around those early Hadoop-based data lakes. We're kind of seeing a second generation data lake happening in the cloud, where cloud object storage has now replaced HDFS as the format, and a massive ecosystem has now developed around that object store in the newer or maybe 2.0 version of data lakes. So these are schema on read, meaning that they can ingest the data without having to convert it into a specific format. Variable structured, it can handle structured data, semi-structured, unstructured data. Depending upon the solution or even the needs, it may or may not be fully ACID compliant and is generally a lower concurrency for this type of data, lower number of users and uses, maybe for things like exploratory data analysis and data science projects. Even if you're not formally doing a data lake, you should ask your cloud analytics provider what support it has for flexible schemas. Can it handle things like HDFS? Can it handle Parquet for Spark, Orc for Hive, Avro for Kafka, other formats like JSON, XML, text, and CSV, and whatever other data formats you have. And in conjunction with that storage option question, can it handle them in that format, or is it going to require converting those formats into some other method for storage? And then the last point here would be analyze in place. Will the data be stored? Will the data be analyzed where it's actually stored, or will it be copied and stored elsewhere for our analysis? Some cloud analytics providers actually separate their storage from their analysis, partially maybe because of the nature of their ecosystem or their products, in which case there may be some additional data movement. Maybe the functionality for analytics is actually an add-on tool, or is provided by a partner tool within their ecosystem, in which case additional data movement and storage is going to be necessary, which could increase the storage requirements for using that particular solution. If you can analyze data in place, then you have a minimal amount of data storage. And we'll come back to that again later when we talk a little bit about query engine capabilities when we get to analyze. But the last two bottom line statements here about storage. You also need tiered storage for right price data retention, which is essential for keeping hot data hot and cold data cold. What that means is hot data is the data that's used most often, most frequently for like dashboards and reports and day-to-day analytics. And then as that data starts to get cold, usually because it passes a time boundary, you might want to move it into alternative storage. Typically, the hot data should be stored in the most efficient, probably more expensive storage. And then once data starts to get cold, you can move it off to less expensive storage. And there should also be a process for marking older data for deletion. And the last point is that when it comes to storage, you need both scalable storage that will grow as your data needs do, as well as elastic storage that expands and contracts for things like temp space, edge, and IoT. So the third of the 5 critical capabilities is optimize. So the two key questions here is how does it improve query performance and how does it handle concurrency? So first up is query optimization. The solution should provide you with the ability to tune slow queries with a query planner or other tool before allocating more compute. If the only option is just throwing more hardware at slow-moving queries, yes, you may get the performance that you want, but it's also one of the paths to bill shock because you'll be paying for that extra compute. So the solution should have other ways to optimize slow queries without having to fall back on just using additional compute. Somewhat similar is storage optimization. There should be the ability to improve the storage efficiency and use techniques like compression to minimize storage scaling. You definitely want elastic storage, but you don't want to scale up storage just because you have to. You want to do it for a good reason. You want to be able to make the most of the storage that you're paying for, because again, scalability and elasticity, if uncontrolled, can lead to unexpected costs. Another thing that can help with optimization is workload balancing. So here it would be the ability to adjust to changes in volume and velocity and switch between load and query optimization. There may be times where you want to optimize the environment for fast data loading, and other times that you want to optimize the environment for fast query performance, and it should be easy for you to be able to switch between the two. Another important concept that you should look for as an available option is resource pools. So the ability to configure memory and CPU pools for specific queries or workloads. So if you know that there are certain processes that are going to consume a lot of resources, as well as being very high priority resources, like maybe the dashboards and reports that people are expecting to have blazing fast response times to, you should be able to allocate resources specific to that. Another way to improve optimizations is projections, which is actually a Vertica specific term, but it's somewhat analogous to a materialized view. But regardless of what you call it, the concept here is the ability to maintain data copies that are optimized for complex and or frequently executed queries. Conceptually, this is not really any different than what a data mart does for a data warehouse. Structures that have been created to handle frequently executed queries, possibly frequent complex analytical operations, and make them available without slowing down the overall performance of the system. These copies need to be kept synchronized with changes in underlying data. Probably the easiest example would be aggregations that need to be updated as the underlying data changes. And one final thing you may want to look at for your environment is the ability to have workload isolation. So the ability to create separate but synchronized copies that are dedicated to specific queries or more likely specific workloads. So you may want to have a separate workload for the dashboards and reports, again, so that they always have great performance. You may want to separate the ETL loads out so that you don't have performance impacts from new data being loaded and existing data being updated. You may want to have a separate workload for the data science team or whoever's doing exploratory analysis, because each of these different usage wants to be able to have access to full volume data, but we don't want to have any increase in activity by any one group or workload slow down the performance of the overall system. So the core bottom line statements here for optimization. A core cloud paradigm, again, is separating storage from compute. However, adding compute to solve slow queries is both wasteful and costly. There should be better options, or additional options, I should say. Optimizing storage with techniques like a columnar architecture or compression will both dramatically lower storage costs as well as improve performance. And concurrency is about more than just handling more users. It's also about preventing performance issues caused by different simultaneous workloads. The key thing to watch out here about optimize is a lot of cloud service providers will offer fully managed services where they will basically tell you that they'll take care of everything for you, which is a really great idea. But if you have no control over any of the configuration options and they do all of the optimizations behind the scenes automatically, some of the choices that they make could end up costing you a lot of money. So look for options where you have some insight into what they're actually doing behind the scenes, and look for solutions that actually give you an option to be able to take control. It's always a delicate balance. One of the key attractiveness of the cloud is managed services taking a lot of the IT responsibilities away from you, but the more freedom that you give up, you also give up some control over things like controlling some of the costs that the solution could end up costing you in the long run. So number 4 of 5 for the critical capabilities of a cloud analytics solution is probably the one you probably want to think of first, which is, hey, what can it do for analyze? So the two key questions here are, can it support our current analytics, and does it provide us with advanced analytics? So first up, cloud migration should not move data beyond the reach of your existing business intelligence and data visualization tools. As for evaluating advanced analytical capabilities, you want to look for the depth and breadth of built-in analytical functions, including things like time series and geospatial. A category of advanced analytics that gets a lot of attention, and rightfully so, is machine learning. And the key thing you should be looking for here is integrated data preparation, modeling, evaluation, and deployment to production capability. As for analytical languages, SQL is standard. However, implementations can vary greatly. Don't assume that it's ANSI standard SQL. So make sure you understand exactly what SQL is being offered and if it has the full SQL capability that you're used to using. Additionally, other analytical languages will probably need to be supported. The easiest examples there would be Python and R are very popular for data science, as is support for their data science notebooks like Jupyter Notebooks. These and other languages may also need to be available in addition to data science, but also for providing you with the ability to define user-defined functions. Because even if the full breadth of functionality that you want exists in the platform, there may be times you want to create your own user-defined functions, and the analytical solution should allow you to do that so you can customize it to your needs. Now, last but certainly not least would be a robust query engine. You want to be able to analyze data not only in place, but in the right place and without unnecessary data movements. You may be moving some of your data from your on-premises data center into a public cloud, but you may also want to be able to reach down from the cloud and combine some of the data that's left on premises into unified analytics. And having an engine that can reach from the cloud down to on-premises, as well as across clouds and wherever data may be, provides you with that ability. Again, without having to require you to move data. There are plenty of times when moving data to a centralized location may offer you some performance improvements, but that should not be the only option. Again, going off of the point I made earlier, if we can do more analytics where data is born, we will reduce data movement, reduce needless copies, and reduce creating additional data silos. You don't want to turn the cloud into another data silo. As far as the last 2 points here for bottom line thoughts for Analyze, different analytics uses and users will have different expectations and often different service level agreements, SLAs, and the cloud migration must not negatively impact any of them. And when you are evaluating advanced analytical capabilities, you should ask the cloud analytics vendor, are the advanced analytics, machine learning, and data science capabilities integrated into the cloud solution? Beware that some cloud analytics solutions do not have this functionality available, but it may not be included for free. So things like machine learning may be something you have to pay extra for. Also beware that sometimes they're provided by a partner tool within their wider ecosystem, which again requires additional data movement to get your data access to that functionality. So again, just be clear when you're evaluating the cloud analytics solution, do they have all of the analytical functionality that you need? And is it integrated into a single solution? So the fifth and final critical capability for evaluating a cloud analytics solution is govern. And the 2 key questions here are, who will govern the solution and how are costs controlled and risks mitigated? So the first concept, governance not included, meaning that managed services are not necessarily governed services. So there are data governance features built into some cloud solutions. You should not just assume that they're there. Verify what options the cloud provider has. One such option you should definitely ask for and look for is cost control. Safeguards should be available to limit scalability and elasticity to prevent surprise bills. Yes, scalability and elasticity are the 2 great superpowers of the cloud, but if they are left ungoverned, they could cause runaway costs, and there should be a way to limit that while still getting the performance that you need from the environment. It's not as much of an issue. Some of this is starting to go away, but be on the lookout that some cloud providers still have egress costs. And this is one of the sort of tricks of the early vendor lock-in. Some cloud providers will let you have free ingress, meaning that they'll let you load as much data or as much data up to a particular limit for free or close to free, but then they'll charge you on the back end if you want to move that data. Again, this is starting to do a trend to do away from this, but don't assume that this is the case. Again, especially if they're offering you free data loading, ask if there are any egress costs associated with moving that data on the back end. Another thing that you should be looking for is access control. So you need role-based access is needed, just like you would need with any of your on-premises implementations. You need to control what data people can access and what they can do with that data. PII, personally identifiable information, and other sensitive data also needs to have its access controlled for regulatory compliance. Another important aspect of security is format preserving encryption to keep data secure both in motion, at rest, as well as allowing you to analyze without decryption. And what I mean by that is that when the analysis happens, if the data is going to be decrypted, make sure it's not being copied somewhere where that decrypted data is exposed, especially if this is happening in the public cloud. So it's an important aspect of security. So our final bottom line statements on govern. Again, managed services must still be governed, and cloud, quote unquote, black boxes, again, those great ease of use, you don't have to do anything, we'll do it all for you, can, if they offer little to no control, configuration, or optimization choices up front, they can expose the enterprise to risks. Cloud economics definitely promise cost savings. The one that's most often cited is CapEx to OpEx, so going from capital expenditures to operating expenditures, mainly that you don't have to buy the bare metal hardware and other infrastructure to install and manage on site and the staffing that's needed for that, and you're shifting that all over to the cloud service provider. However, as data scales exponentially, and it is, and it's not going to stop, costs can skyrocket with cloud solutions if they're not properly governed. So in the long run, cloud computing can actually cost your enterprise more money than on-premises solutions if it's not properly governed. And finally, access control, cybersecurity, and encryption and compliance must all be included. And a term that a lot of analysts are starting to use is connected governance. And what that means is cloud and non-cloud governance, meaning all of your data, wherever it is, on-premises, public cloud, private, hybrid implementations, it all needs to be under the purview of governance. And that connected governance term is really speaking to the fact that under cloud architectures, especially hybrid architectures, not all of that data that's governed is on premises anymore. And that needs to be factored into. Oh, I did forget one of my points there. I'm sorry. I forgot to mention public exposure. So my last point there would be your organization already uses the public cloud more than you may realize. Two very simple examples are smartphones and Gmail. Nearly every smartphone app is connected to a public cloud service automatically in most cases. And if you're not using Gmail, most of us use some other web-based email for our personal email. Probably against your corporate security policies, but let's face it, a lot of us use these services to move data from our work computer to our home computer. And you may have shadow IT efforts going on in your organization that are taking advantage of some free options in cloud analytics. And you need to assess that as part of your overall governance assessment of cloud analytics solutions. So that's it for the 5 critical capabilities of evaluating any cloud analytics solution. Again, that's deploy, store, optimize, analyze, and govern.
Is data gravity a barrier to becoming a data-first digital enterprise as we go through this multi-hybrid cloud transformation?
Okay, I guess on that last one, I guess the answer to the previous one, I think, was more of an encryption aspect, is making sure that there is, if you have sensitive data, you may have situations where you're not allowed to, in that particular instance, to move certain data to the cloud. So a hybrid architecture might be necessary to keep the sensitive data on premises and then leave the less sensitive data in the cloud. There's also options, if not just for encryption, you also can anonymize data. So maybe you can move some, in the case it's a higher education, maybe you can move some demographic data describing the students without exposing the identity of the students to the cloud so that you can get access to analytics that way. So there are plenty of options there. As for the data gravity thing, I think that's speaking more to the idea of limiting data movement because data is definitely becoming so large now that every time we move it around, not only does it put data at risk, but that unnecessary data movement, you shouldn't have to bring your data to the analytics. You should be able to bring your analytics to your data and minimize that data movement as much as possible. I jokingly call that, let the data work from home. Bring your analytics to your data.
How does a hybrid architecture limit analytics tools and impact performance?
I wouldn't say that it limits analytics tools unless you're talking about limiting what data goes to the cloud. I mean, a hybrid architecture still allows you to use all of the data. You may only be moving some data to the cloud. You want to look for a hybrid architecture that provides you with the same full functionality on premises and in the cloud. So if you're moving to the cloud to get access to some advanced analytics functionality like machine learning, a true hybrid architecture should also allow you to have that functionality on premises as well. So you shouldn't have any limits in terms of the analytical functionality. Performance-wise, I mean, it varies. I mean, on premises, depending upon the configuration, may be your best source of performance. But then again, cloud architectures may be more performant for a particular analysis. But I would say a true hybrid architecture should be largely transparent to the user. You should get the same analytical functionality and the same performance wherever the data is, whether it's on premises or in the cloud.
Thanks for that answer. How will edge architecture change because of increasing data gravity?
Edge is an interesting thing. I kind of left that out of the presentation. Edge is a part of sort of maybe the leading wave of the Internet of Things. One of the things there is that Edge and IoT can actually function and often do completely independent of the cloud. They're not necessarily needed. I live in a part of the United States that has a lot of agriculture. So farming here uses a ton of edge computing. I don't know if anyone's climbed into a tractor or a harvester lately, but it's like climbing into a space shuttle. There's a tremendous amount of onboard technology that is doing storage and compute on the tractor and the harvester to keep that to optimize the use of that equipment. And when the cloud gets involved in that, it's typically for the transportation of that data back to either on premises or wherever the data center may be that may be doing things like remote monitoring or preventative maintenance. Because in the case of the agriculture example I used, we want to make sure that we fix those machines before they break down, because not only would it be incredibly expensive to the farmer, but it can have a huge impact on the agricultural economy. So a lot of the computing that's happening at the edge is kind of independent of the cloud, but you may be bringing some of that sensor data back to build a machine learning model to help improve predictive maintenance, and also give a heads up for remote monitoring that to catch a problem with the machine before it breaks down. So it is kind of a combined architecture. Also, in the case of where I live, a lot of that is also in rural areas with very limited connectivity. So there's not a lot of cloud computing happening there. So a lot of that is happening at the edge. I kind of probably rambled a bit on that answer. Sorry.
No, that's been great. A follow-up question, what are yours, Jim's preferred analytics tools today?
Well, you're asking someone who works for a vendor. So obviously I prefer my own product, which is Vertica, a unified analytics platform. But prior to joining Vertica, I mean, we support a robust architecture and ecosystem of other tools. I am a Python programmer by trade, so I've done a lot of machine learning and data science in Python. And one of the things I actually think I forgot to mention is one of the things you should be looking for in a cloud analytics solution is the ability to import work you've already started someplace else. So if I've started to work on a machine learning model in Python, I should be able to import that into the cloud analytics solution without having to start from scratch. So looking for and acknowledging the fact that everyone's going to have their own preferred tools, and the cloud analytics solution shouldn't force you to stop using those tools. They should be able to work together and be able to leverage the productivity that you're getting from the cloud analytics solution.
Sure. Jamie,
I'm laughing at the very biased response.
I know. Figured you would give you a little softball question to end it up. And this has been really great. And thank you so much. It's been extremely insightful.
Thanks, everyone.